Hello everyone. In this video we will see shear force due to live load, shear force due to live load on a internal panel. We are discussing about the panel, and in the previous class we have calculated the bending moment in the panel. So the size of the panel is the width of the panel is 2.5 meter and the length of the panel is 5 meter. So this is the deck slab that we have, and we are putting it on the girder. Okay. You can see the previous recording to understand what we are on to. So in this video, we will see how to find the shear force due to live load. We have calculated the bending moment on the internal panel due to the live load. So for the bending moment, we have kept the load of the track exactly at the middle, exactly at the center, so as to get the maximum bending moment. Okay. In case of shear, we have to put the load in different ways, in a way that we will get the maximum shear. Okay. So I will draw the cross section of the girder and also the deck, so as to understand how to place the load to get the maximum shear force. So this is your carriage way. Then you have the depth of the wearing cord, 80 mm depth of the wearing cord we are providing. Then you have the depth of the slab, and here you have the longitudinal girder. So again you are having here the longitudinal girder. Center to center distance between the longitudinal girder is given, that is 2.5 meters. And here in the panel, you are providing the load. You are providing the load of the track. And the width of the track is 0.85 meters. So we have to place the load in a such a way that the entire, the dispersion should be within the span and near to the support. So in that way we need to place the load on the track so as to get the maximum shear force. And the depth of the wearing cord is 80 mm and the depth of the slab is 250 mm. And we can learn how to find the dispersion. The dispersion is in 45-degree direction. Okay, so this is 80 mm depth is 80 mm and this deflection will also be 80 mm. And since this depth is 250 mm, this deflection will also be 250 mm. So this dispersion in the horizontal direction, the distance in the horizontal direction with respect to this dispersion is 80 mm plus 250 mm, and this is also 80 mm plus 250 mm. Okay. So the dispersion I will calculate here. 0.85 is the width of the track plus 2 into 0.08 plus 0.25. Okay, so this you are getting it as 1.51 meter. Its dispersion width or length is 1.51 meter. So we need to place the load such a way that the center of the track is at a distance 1.51 divided by 2 from the edge of the girder, from the edge of the beam. So this is 1.51 divided by 2. Okay. Now we can find the effective width, and the formula of the effective width is B effective equal to alpha A bracket 1 minus A divided by L plus D1. Now you need to understand, when you are finding the shear force, you are treating the shorter span as length of the slab. So this is the length of the slab and this is the lateral dimension of the slab in this particular case. Okay, so this is the longitudinal girder that you have, and you are also having the cross girder. You see the previous video, you can understand. The width of the longitudinal girder is 300 mm and the width of the cross girder is also 300 mm. Okay, now you see the center to center distance between the longitudinal girder is 2.5 meter and the center to center distance between the cross girder is 5 meter. Okay, so you can find the clear width of the panel. So clear width of the panel equal to 2.5 meter is center to center distance between the longitudinal girder minus width of 300 by 2 minus 300 by 2. You can directly take it as 0.3 and you are getting it as 2.2 meter. The width of the panel is 2.2 meter. Similarly, the length of the panel. So in the length of the panel, you have the cross girder. Okay. So in the length of the panel, the clear span will be 5 meter. 5 meter is center to center distance between the cross girder minus 0.3, and this is coming as 4.7 meter. So this is 4.7 meter and this is 2.2 meter. The clear dimension of the internal panel. Okay. Now, to find this, we need to find alpha. Alpha value, it depends on B by L dash value. Okay, and we are finding the alpha value from the table given in IRC 112. Okay, and what is B? B is the width of the panel and L is the length of the panel. I told you to calculate the shear force, the 2.2 is considered as the length of the panel because this is what we are considering, and the lateral dimension, the width of the panel is 4.7. Okay, so B by L equal to 4.7 by 2.2. This is coming as 2.14. Okay, 2.14. Now for alpha value, for B by L equal to 2.14, we are getting it as 2.6 from the table. Okay, so we got alpha value, and what is A? A is the distance of the centroid of the load from the nearest support. So A is nothing but 1.51 divided by 2, and L is length of the panel. The length of the panel is 2.2, and B1, we will see what is B1. Okay, see, this is the track that you have. Okay, the width of the track is 0.85 and the length of the track is 3.6. So what is B1? B1 is nothing but dispersion. See, this span you are considering it as lateral span in the calculation of the shear. So B1 is dispersion of the lateral dimension of the track up to the wearing code. Up to the wearing code means 3.6 plus 2 into 0.08. Okay, so B1 is, you are getting B1 as 3.76. Now again, put all the values in the formula and find the effective width of the load on the slab. So B effective equal to 2.6, that is the value of alpha, into A is 1.51 divided by 2, 1 minus 1.51 divided by 2, that is again A, divided by L, 2.2, plus B1. B1 is 3.76. Okay, so B effective, you are getting it as B effective, you are getting it as 5.05 meters. Okay, now you can find the intensity of the load. To find the shear force, you need to get the intensity of the load. Okay, intensity of the load, equal to load of vehicle into impact factor. So whenever we are considering the live load, we also have to consider the impact factor. And what is impact factor? You can see in the previous recording. divided by effective area. Divided by effective area. Okay, so we have seen the dispersion in the length direction, that is 1.51, and we have also seen what is the dispersion along the width direction, that is effective width. So this is what is effective width. Okay, so dispersion along the width is 5.05. So this is nothing but your effective area. So load of vehicle, we are placing only one track of IRC class AA. The load of that is 350 into the span of the panel is 5 meter. For the 5 meter, the impact factor will be 25%. You have to increase it by 25%. So you need to multiply 1.25 divided by effective area. Effective area is width is 5.05 into dispersion along the length is 1.51. Okay, and the intensity of the load that you are getting it as 57.37 kilonewton per meter. Okay, now you can take the span. So this is the span of the beam. For the shear, the span is 2.2 meter, and the intensity of the load you have to show. So this length, the length of the UDL is nothing but the dispersion length. This is 1.5. Okay. Intensity of the load, just now we have calculated, that is 57.37 kilonewton per meter. Okay. And the shear will be maximum at the left support, because the load is near to the left support. The shear will be maximum in the left support. So this is 56.9 kilonewton. This is shear due to lying load. Okay. We also have to find shear due to dead load. Shear force due to dead load. And in the previous class we have calculated what is dead load, and dead load is uniformly distributed over the entire panel. Dead load is uniformly distributed over the entire panel, and whenever you are considering the dead load, you don't have to consider the impact factor. Impact factor is associated with the live load. Okay, the intensity of the dead load is 8.01 kilonewton per meter square. We are considering 1 meter width of the slab, so it will be kilonewton per meter. Kilonewton per meter. The span is 2.2, and the shear will be the same on both the supports. You can consider any support. Here is 8.81 kilonewton. So in this video we have calculated the shear force due to live load and shear force due to dead load for the internal panel subjected to IRC class AA tracked vehicle. So in the next class we will see the design of internal panel. Thank you very much for watching this video.